Okay, so in this video, let's talk about the problem of the Tower of Hanoi. So I'm going to proffer a Pythonic solution to this problem. But first, let's discuss this problem. All right, so the problem of the Tower of Hanoi involves three towers, and one of the towers has got, a given number of disks. So we have to find a way to move the disks from one given tower to the destination tower. Right, so as you guys can see on this graph or on this graphical representation, we have three disks on this first tower, and then we have to find a way to move these to the destination tower, which is this tower, via this middle tower. Right, so we have to follow certain rules for us to achieve that. The first rule is we can only move the disk that is at the top. Okay, we cannot move these other two bottom disks for as long as we have these smaller disks on top. That's number one. Number two, you cannot have a larger disk sit on top of a smaller disk. You cannot have that. So these disks are arranged in ascending order. So you have to maintain that order. Okay, that's number two. Number three is you can only move one disk at any given moment in time. Right, so in this instance, I cannot move the two disks or the three disks at once. I can only move this one first, and then I can move the other one. All right, so let's try and solve this problem, and then I'll explain further, how we're going to deal with it. All right, so we want to move them to this destination, so we need the support of this tower. That's why we have this middle tower, because it supports, right? So then I move this here and then take this to the end, and then this now becomes the support, and then take this here and then take this here. All right, boom, I've finished this in 7 moves. So I need a minimum number of 7 moves if I have 3 disks. Right, let me restart again and show you something. If I increase the number of disks, you will notice that the number of moves, the minimum number of moves, increase exponentially. That is, they double. If I increase again, they are doubling. Okay, each time I increase with 1 more disk. Right, so there is a formula to calculate the number of moves that you need for any given number of disks. Right, so we use this formula. It's 2 to the power of n minus 1. All right, 2 to the power of n being the number of disks. So if we have 3 disks, we say 2 to the power of 3 minus 1, which is 7. That's why we have a 7 here. If there are 4, 2 to the power of 4, which is 16 minus 1, that is 15, and so forth and so forth. Right, so I will name these towers. All right, so the first tower being the origin tower, the second tower being the auxiliary tower, the third tower being the destination tower. All right, so that's how you name these towers. All right, and now we want to see how we can do this. We can solve this problem in Python, okay, in a Pythonic way. So we have a way to do it. We use a function. And so let's jump into our text editor and try and find a solution to our problem. The first thing we want to do is want to look at our this graphical representation. Let me bring it up so that you guys can see. All right, so this graphical representation, we have disks and we have towers. Okay, so we have 3 towers and a given number of disks. So we need a way to represent this in our code. Okay, so we're going to use a function called code the tower of Hanoi, tower underscore Hanoi. All right, so in Python, the way we create a function, we use the def keyword and then we name the function. The way we name our function is similar to the way we name our variables. Okay. So here, like I said, I need a representation of the disks in the tower. So I'm going to pass these inside here. So I'm going to say n, which is the number of disks. You can pass any number of disks that you want. And then we have the origin tower. We have the destination tower, and then we have the auxiliary tower. All right, so the way I arranged this is that we are supposed to move n number of disks from the origin to the destination. So this is how you're supposed to put it in code. Okay, so the way we're going to solve this, we're going to use a concept that we call recursion. So recursion is just a function that calls itself. But the concept involves breaking down a bigger problem into smaller problems, and then we apply solutions to the smaller problems. So once we apply solutions to the smaller problems, we are actually solving the bigger problem. It's just like when I want to eat a bowl of rice, I have to, that's a problem, right? So I have to use a spoon to eat the rice. So the moment I'm using a spoon, those are smaller solutions to the bigger problem, right? It's similar to that. So here I have to create a base case scenario. So if n, the number of disks, is equal to 1, this is an easy solution, right? If the number of disks is equal to 1, we just have to move that disk from the origin to the destination. So we can say print, I'm going to use the f string here. We want to move n disks, from origin to the destination, to destination, just like that. That's what we want to do. If I can bring this up, let's say we had 1. Unfortunately, this in this game you cannot go beyond 3 disks. I cannot lower these disks to 1, right? So if I had 1 disk, let's assume, I could just, it's easier, right? I could just move it to the destination. That's it. That's what this, the base case scenario, right? Else, if we have more than 1 disk, now we can call this recursion function. It has to use recursion. All right, so we have to move n-1 disks. All right, so I want to show you what this simply means. Okay, so when we say n-1 disks, what we are referring to these disks. Okay, these 2 disks. If I had 4 disks here, I will be referring to the 3 disks minus 1 minus this n-1. It simply means we have to remain with the 1 here and remove the others, the rest. That's what we are talking about. That's why we're calling it n-1. So that's how we do it. We remove n-1 disks. From where? Where are we removing these n1 minus disks? So I'm gonna move this to here, and then this one to here, and then this one to here. So we remove n-1. Right now I've moved n-1 disk. From where? From the origin to the support, to the auxiliary. So that's what we have to show here. n-1 from the origin to the auxiliary. Via what? Via the destination. We use the destination as our auxiliary to move these n-1 disks. That's what this means. All right, and then I have to print this statement after that, and then from there what we need to do is take this to here, right? And then here we have to move the n-1 disks from this auxiliary to the destination via the origin, right? So this to the origin, this to the destination, and then this to the destination. Boom, we're finished. So we have to represent that in code. So we use again, we call the function to call itself n-1 disks. We want to move them from the auxiliary where they are to the destination via the origin, just like that. Okay, so that's what we did. That's what I just did. I took the remaining one, the n-1 disks, from here, the middle one, to the destination via the origin. Okay, as simple as that. All right, with these few lines, you are done. Now we can call our function, the Tower of Hanoi, and then we can pass in the number of disks, which is n up here. Let's put 3, and then the origin and blah blah. We can just put something else. We can say A, B, C. A is our origin, and then C is our destination. So the way you call your function is you must replace these with the exact values that you want. Okay, so and then our auxiliary is going to be B, right? So that's how I'm going to call the function. And so if I save this and run this, so I want to bring up this the solution. This is our solution that we have with Python. And so I'm going to restart this so that you guys can actually see what I'm talking about. So this is our A, this is our B, and this is our C. I'll have to mark that clear so that you guys can actually see. So the solution says move one from A to B. I'm going to move one from A to C, sorry. Okay, A to C. And then move two from A to B, move two from A to B. And then move one from C to B, from C to B. And then move three from A to C, A to C. And then move one from B to A, B to A. And then move two from B to C. And then move one from A to C. Doom, the solution. Boom, there you go. We have our solution. If I'm to increase the number of disks to 4, we can still have a solution, right? Let me try and put a 4 here. Now we have 4 disks. Save, run the solution. Is too long, I think. Yeah, this is a long solution, but we can still have it. Okay, now we have to move one from A to B, and then move two from A to C, and then move one from B to C, and then move three from A to B, then move one from C to A, and then move two from C to B, and then one from A to B, and then now we can move from A to C here, and then B to C, and then B to A, and then C to A, and then C to A, and then B to C, and then A to B, and then A to C, and then B to C. Boom, 15 moves, all done. These are the 15 moves that we have. All right, so as you guys can see, we have just, provided a solution to the mathematical problem of the Tower of Hanoi using Python. You can do the same. You need to study this, look at this function and see how it's working. You'll get an understanding of, how these things work. All right, I hope you guys understood. I'll see you in our next lesson. For now, I'm out. I'll see you. Bye-bye.